Hi, and welcome back to the fourth section of the course, Generators and Iter Tools. In this section, we will learn about some scenarios where a list comprehension does not really help us at all, and in fact will hurt our user's experience. We will learn about generators as one potential way to combat some of these issues, and we'll also explore some infinite data sets and how we can work with them and use them to do some cool stuff. This is the first video in our section, Some Problems with List Comprehension. In this video, we'll take a look at some of the reasons that a list comprehension might actually hurt your user's experience. We will learn about the two primary considerations that impact your user's experience. The first and most pressing consideration is time complexity. In other words, how long does an operation take? The second consideration to keep in mind is space. In other words, how much of the system's RAM is consumed with a given operation or object. Let's go ahead and create a new file called generators.py. The first and primary issue of annoyance for users is going to be time complexity. Anytime the system halts or becomes unresponsive, even if it's just for a brief window of time, a second or two, that really feels buggy to the end user. It feels as if the program is not working right. It feels as if the program's broken. And unfortunately, list comprehensions, because they do their entire list comprehension all in one instruction, sometimes will cause a bottleneck here, and that will seem like unresponsiveness or brokenness to a user. Consider the following. So we'll go ahead and we'll say from future functions, import isPrime. Now, we haven't covered functions yet, so I'm not going to go into what isPrime is or its implementation. We'll cover that later. But we'll just say this is a function that will tell us whether or not a given number is a prime number. Now, let's collect all the primes between 1 million and 1,200,000. To do that, we'll just do a list comprehension that collects x for all the x's in our range of 1 million to 1,200,000 if x is a prime. Now, we can do some simple profiling by collecting our start time. We'll say import time, and we'll say start time is now, time.time. And then at the end, we can use format strings and using our F format specifier, which lets us use our local space, we can actually do some cool stuff like just do the math right there to tell us how long it's going to take there. Let's go ahead and we'll also print our primes. Now when we go ahead and we run this, we should see that it takes about, 4 seconds, 4 and 19 seconds. We see our list of primes there. Now, if you needed to collect every single prime in this range, this is probably as good as it's going to get. It's going to take 4 seconds to calculate that. And that's on my computer. You might get different mileage on your computer. But now consider that we're collecting these primes for some cryptographic function, and we just want the user to pick some of them. So we'll say for prime in primes, if we ask our user keep prime, and again we'll use a format string, and we'll say if that starts with y, then they said yes, they want to keep it, and we'll keep a list of those. And let's just say we want 4 of them, so we'll say kept primes, append this prime, so we're adding this prime to our collection of kept primes, and then we'll say if our length of kept primes is greater than or equal to 4, then we'll just break. So if we get our 4 primes, then we got all of our primes, and we'll say print keeping kept primes. And so now when we go ahead and we run this, we'll see again that it still takes, 4 seconds, 3.5 seconds to generate our list, 4.5 seconds. And it's asking us now if we'd like to keep some values. So we'll say yes. We'll just say yes to the first 4. So we see that we did keep our first 4 primes. Unfortunately, that first couple of seconds, it really seems like nothing's happening with the program. We can help combat that through some tricks that we're going to take a look at in our next video. We really probably don't need to calculate the whole list. Probably can calculate this on demand as each value is being asked to the user. And it'll provide for a much better user experience. The other consideration is space. Consider, for example, if you had a big library of books. It might be somewhat difficult to hold the entire contents of all those books in your RAM at once. It was really a problem back in 32-bit systems. You had a hard memory limit of 2 gigabytes for any process. They came along with paging, which uses hard disk space to help increase that. However, that can lead to thrashing and just a less than ideal user experience. In 64-bit days now, it's much less of a concern. Also with paging, it's really not much of a concern. But really, just consuming tons of the system's resources and memory for your process is just bad housekeeping, and other programmers won't appreciate it one bit. So be a good citizen and let's not use up all of the user's memory